Okay, let's do our midterm topic review. This says econometrics. We are probably more appropriate calling it empirical analysis or empirical demand. We've focused more on sort of a couple of ways to, or I guess 4 ways to look at a demand equation. Econometrics is a much bigger topic, and one that we'll revisit with some more. To see some other types of analysis. This is our Friday class meeting of the 6th week, and it follows what we did on Wednesday. So on Wednesday I told you there's 2 major topics on the exam. The first being sort of supply demand equilibrium analysis, that has those 2 different forms that I wrote on the board of price analysis equations. And of course, both of those price analysis equations depend on knowing something about either the slope of the demand curve, also the slope of the supply curve, and the elasticities. Okay, so you need to know something about those, and so empirical analysis or econometrics is our tool to get that done. Okay, and so what I'm going to do is I posted a review handout that answers questions. We had I guess it was a practice questions midterm on empirical economics or econometrics. And so I filled that in, written in some notes, and posted that handout. And so what I'll do is just talk through that. I'll use that as my source to go through and sort of explain what I'm expecting and what format I expect on the exam. So you can pretty much guarantee you'll see a question that looks like that handout. That practice question. It'll have different results posted, but used, but but it's a staple question. So we'll talk through that one, and at the end of this, I'll talk about some variations of questions that might be included. Okay, so this table here is regression output for pork demand. All variables are given in levels, so that lets you know that none of these, pork price, beef price, or anything like that, are in logarithms, and none of them are in ratios. Okay, so it would tell you right there, and I would also tell you right here. And I would also put a big note saying, note that this is income divided by some price, or this is poultry price divided by the beef price, if it was going to be that way. Organization of the table will always look like this, so it's not exactly what you get out of Excel, but it's close. This part is from Excel, and then I think I just copy some information from the top and put it here at the bottom. So it'll always look like this. So go down here to find your R squared and F statistic plus this F significance of the F statistic. I'll always list these variables. I'll let you know what type of variables they are. If they're in logarithms, it'll say so. If they're income rate, price ratios, it'll say so. And then again, I want you to focus on what's there, how do you interpret it, how do you explain it. And this is my number one suggestion. Before you get into the questions too deeply, there'll be, right, so you'll get this, and there'll be something like A, B, C, and D, 4 sort of basic questions that you work through, and they'll have sort of different learning objectives. 2 of them might be focused really on the quantitative interpretation. So maybe talking about the pork price effect, maybe comparing it to the beef price effect, maybe looking at how to calculate the elasticity. And then there might be something about how would you predict, given some prediction on the change in income, how do you expect this to affect the quantity demanded, right? So any of those sort of basic sort of functions you can use from the numbers. But there'll also be a couple of questions about, are these good quality estimates? What would you expect the impact to be if you changed, if the poultry price wasn't included? What would you expect it to be if we added the price of wheat, or the price of bread, or the price of some other good in this pork demand equation? So things like that. So what I think is important is, given that there's going to be 3 or 4 sort of sub questions, small questions attached to this, get yourself oriented to the table right away. So give yourself a minute just to read through it, look at the estimates, look at, maybe even just go through and make notes for yourself. Which coefficients are significant if you're using the t-statistic, or if you're using the p-value. Just make a note for yourself. Even if you don't see those questions yet, it might be good, and it might give you some information to already have in your mind for when you get to one of those and you have to write a small, a 2 or 3 line paragraph explaining something. It'll be useful to not have to go back and sort through all that. So maybe looking at the whole picture here and trying to think it through is the right thing to do. So we have all the example questions coming after this, but my suggestion is focus on what's there. How would I interpret this? How would I interpret this? How would I interpret this? Remember that these coefficients, once you know that they're all in levels, they get this type of interpretation. The change in the quantity demanded of pork per unit change in whichever one of these right-hand side variables I'm looking at. So throughout these notes, it'll say RHS for right-hand side. If this were a different type of model, a log linear model, we would interpret them as elasticities. Okay, so I can promise you somewhere on the exam you will be asked to write the actual equation. What does the econometric equation for pork demand look like if you've been given these sets of results? And so it's really just a matter of how do you want to write it. Okay, and so in the handout there I wrote Q of pork, and then just A, B, C, D, and E for the coefficients. You can actually plug the numbers in if you want. But you have to declare the variables over here, right? And so in here I've just written in brackets pork price, beef price. I don't, you don't have to get tricky and put X sub P or P sub pork or whatever, like in some of the handouts we've had. Just be clear. Just make it very obvious what you're doing. The important parts here are that you have coefficient times variable and that they're all added together. Okay, they're all additive. And then the last sort of important part is the error term. And I leave it off a lot. And so you can expect that if you put it in, that's good. If you don't, it's not a costly error because it's the kind of thing that I'm prone to not typing. But it is important if I make a question about it. Let's say I gave you in a question this econometric equation and said spot the error, then I would expect you to note that the error is that I actually left out the error, right? That's a very meta type question, but if I give you some regression equation and tell you take this and convert it to another type, linear with a numeraire, right? Rewrite this equation with a numeraire, you would be expected to do that too. They always, if it's a regression equation or an econometric equation, it always has an error term at the end. And that's really, that's the thing that says, if this is the predictive value over here, we're predicting quantity here through all of these terms together. This is the actual. Well, the predicted and the actual won't be the same very often. And so the U is the thing that makes this an actual equation. Right? It just catches whatever the difference is in those two things. And again, like I said, there are 3 other model types: linear with a numeraire, log linear without a numeraire, and log linear with the numeraire. And remember, the numeraire is just one money variable, price, or it could be income, that we use and divide everything else by that. Okay, so it goes away. Let's say we were using the poultry price, then the poultry price is no longer part of this equation. It drops out, and then when we look at the beef price, we are looking actually at the beef price relative to the poultry price. Okay, and so just to remind you, we do have a handout on this that gives the 4 types. We did a lecture in class where I wrote all these things in, and it's that handout that has the 4 types, and it goes all the way through to show you how to calculate the elasticities for all 4 of these models. It gives you those formulas. And remember, you can have a handout, or your own sort of handout that you prepare where you use your own handwriting to write everything. And you're allowed to use that on the exam. Yeah, so these are the 4 types. And so conversion of, right, you could actually think of this question as, what if I want the numeraire to be the price of C or PC? How would you convert this to a form that enforces homogeneity or that has a numeraire? Well, this is that conversion, right? Because both P and M, the price of the good, the own price, and the income have been divided by that numeraire. Note, I did leave off the U's here. They should be there. These are intended to be regression equations, regression models, so they have error terms at the end. You're responsible to know these 4 types and nothing else, okay? And by that I mean the format, okay? So I'm not saying that you only need to know it with 3 variables, because you might think, I mean, one question might be, what kind of information would you want to, maybe not the demand for pork, but if the question was something like the demand for fertilizer for a farm producer, what kind of things would you put on the right hand side? The obvious one is the own price, and then it's what prices are relevant to a fertilizer purchase. Could be the output price. If it's corn, it's, that's an important one. So the corn price would be a good one to put there. Maybe the farm size. So there could be all kinds of things that you could do. These are all types of models, and remember the numeraire models. The difference in these two, type 1 versus type 2, is these are not linear. Okay, they're linear in the logarithms, but when you draw them out in levels, quantity versus price, they'll have some kind of curve to them. These will be straight line models. And then, of course, the numeraire models have homogeneity. They are guaranteed to have all the elasticity summed to 0, or if you prefer, they have no money illusion or no inflation. Okay, the question 2 here is on justifying the quality of the overall econometric model or the overall regression. And here's sort of an example of how I'd write about the results that we saw way back here. Anyway, focus on correct interpretation of statistics, and only really the ones that describe overall model, because that's what they're for. R squared and F test are the ones that are really focused on everything. Some people like to say, well, 3 of the 4 t-tests are positive. That's not terrible, but it's not exactly what that's designed to do. There are some reasons that we're not going to cover in this class why that might be frowned upon. But the R squared is just a direct proportion, right? So it's a measure between 0 and 1 of how much variation in the left-hand side, in our case, quantity of pork, is being explained by everything altogether on the right-hand side. So put everything that's on that side, how well does it explain it? And then the F-test is sort of like a test of how powerful that explanation is. So it starts from a null hypothesis that there's no explanatory power in whatever the collection of right-hand side information is. In other words, the mean variable, the annual mean quantity purchased of pork is a better predictor, or just as good a predictor as whatever regression we've come up with, right? Remember, all of these are about how good can we predict the future or changes to quantity demanded. If you had no explanatory power, then it would be best just to say we expect last year's quantity to be repeated. The alternative hypothesis, if you can reject, based on an F-test, that null hypothesis here, then you say there is some explanatory power. It just means we have some. We have enough statistically to say that we are 95% confident in our model having some positive measure of explanatory power. And then remember, there's this F-test with a significance value. That significance of the F-test is just like a p-value. So you can use the benchmark of 0.05, and that's equivalent to saying 95% confidence. Okay, So once we get through this sort of statistical quality overall, we can talk about interpreting the results. And so here in these questions, you can see I've combined both interpret the result and talk about statistical quality. So the statistical quality is about the t-test. You can use the p-value or the confidence interval for that. But really it's about saying it's some effect that is not equal to zero. That's the null hypothesis for the t-test is always whatever variable this is. If it's the income has no impact on how much quantity, on the quantity of pork consumed. Well, that's the null hypothesis. If you reject that, right, by either getting a large t-value, a small p-value, or a confidence interval that does not include zero, then you have a 95% confident result. The interpretations, linear model is always going to be the change in whatever's on the left-hand side given a 1 unit change in the right-hand side. For the log linear, it's always going to be the percent change in the left-hand side given a 1% change in the right-hand side. And models have a numeraire. This gets a little more complicated. You could say first it's typical. The typical thing is to say that everything on the right-hand side now is in real terms. So it's real income or the real pork price, and that clears everything up. Okay, so in this case it would be the change in pork demand from a 1 unit change in the real pork price if we were using, say, the price of poultry as a numeraire, so that it was really price of pork divided by the price of poultry. It's also appropriate to say it's a 1 unit change in response or as a result of a change to the price ratio. Okay. And you can think for yourself why people might just say the real price instead. It's because there's two ways to change a price ratio. A 1 unit change in a price ratio could happen because the numerator changes, because the denominator changes, or because they both change relative to each other. Okay, so this particular handout, this particular practice question had the own price effect separated from the cross price effects. So everything here is the same, except for we have one sort of additional factor to consider, and it's the sign of the cross price effect. That's an error. I'm sorry, that says own price effect should be 0. It should be less than 0. P and Q, this is correct. P and Q are inversely related. So this should be either say negative or I think I meant to type less than 0. So be sure you understand that. So own price effect should be negative, but cross price effects can be positive or negative. We really have only focused on the positive effect because we've been looking at a sort of a small subset of food goods. But really, when the beef price increases, if pork quantity consumed goes up, it's because they're substitutes. It's because beef gets more expensive relative to pork. I shift consumption away from beef towards pork. Okay, that's the story we told early in the semester. It's a substitution relationship, and that's typically what we're looking for. But if you see a negative one, it's indicative of complementarity. Okay, so I don't know, hot dogs and mustard or hot dogs and buns or something like that. If the price of hot dogs goes up, you might see mustard consumption fall. Okay, so you get this negative relationship. Okay, and then the income effect. So we've split all these up into different questions here. Income effect is positive. We expect them to be positive, but they can be directly interpreted. All right, so if it's a linear model, it's a $1 change in my income gives me 0.37 units increase in quantity demanded. If there's a numeraire, we might call that real income. That's usually the easiest way to describe that. And then, of course, in a log linear model, we'll be talking about an income elasticity. Income effects themselves are pretty intricate. It's kind of its own topic that we don't really cover. We haven't covered it, and we don't talk about it much because it's not a key part of a price analysis class or an ag prices class. Just so you know, a negative income effect is possible. It's an inferior good. It's one that once you start earning enough money, you eliminate it slowly from your consumption basket. An income effect that is relatively small indicates necessities. It means you don't, more income doesn't make you want more of it. It's just it's just something that you don't increase that much. And then, of course, large income effects tend to be luxuries. So as your income gets large, you consume them, and then you consume them more and more. That's where more disposable income goes. So again, we've been mostly focused on ag prices and food prices. Not to income effects aren't a big piece of what we want to do. Okay, then the final piece here is on elasticity. So calculate the own price elasticity. If you look at the handout, I actually calculate all, 4 elasticities in that handout. But calculate the own price elasticity, provide an interpretation, show your work. Show your work so that if you mess up, I can see that you got the formula correct and give you most of the credit. Okay, or maybe all the credit if it's really a mistake that has no effect. So for a linear model, you'll need additional information to calculate the elasticity. That's why this table is given to you, right? So if you weren't using it, or if you were thinking about not using it, that would be a bad thought. Use it. The formula for elasticity you should know, and if you have trouble with it, just write it down on your handout or on your personal sheet that you get to bring. It's the change in the quantity divided by the change in the price over that same ratio inverted for the levels. Okay, so it means you need to know the derivative. In our case, these econometric equations, it's the coefficient right here, and you need to know one point at which you're going to calculate the elasticity. So P and Q, we need some pair that is a point on the graph or a point in the data that we're going to use to calculate our elasticity. For empirical work, we just use the average price, quantity, and income that comes from the data. That's why this table is up here. That's because those are really closely related to the regression estimates. The regression line has to pass through the means of the data, and that means that we know these things all sit on sort of the heart of the regression line. So there may be other places you want to calculate elasticity. There may be other sort of tricks of analysis or focus of the analysis that causes us to change that. But for this exam, for sure, we're going to use these points. Again, so if you're asked to calculate multiples or more than one of these elasticities, it's always a problem. People tend to think this ratio isn't changing, right? So they'll just change the coefficient and multiply it by the same number every time. At least that's the error I saw most on the last exam we had. So keep in mind, take the coefficient that goes with that variable, multiply it by the average of that variable. So if you're calculating the elasticity of beef price, you need the coefficient that was estimated for the beef price, and you need to use right here the average beef price. Only this one piece in the denominator of that ratio right there, P over Q, that's the only thing that stays the same. So these two pieces need to be adjusted for each of these. Okay, well, that gets us through our handout, and that handout's posted. I do want to give you just a little bit of what I consider as I'm looking through and sort of making notes as I get ready to write the exam. Again, looking at the handouts I've given you and really that sort of parameters for the exam, which I consider to be the topics that are the main learning objectives. Other question types that would get at those would be a partial information question. So if I gave you an elasticity, could you backtrack? Could you tell me what the estimated coefficient was if you know the price and quantity? I mean, that's just a reversal of the mathematics, right? Using your outcomes. So if you have some estimates from a regression equation, they tell you the income effect, could you use that to predict what the quantity response is? Right? If I tell you income is going up by $2,000 or 5% or whatever, can you tell me what the quantity change is? That's just another way of doing an interpretation, is actually asking you to provide the analysis, and you would need to know by how much, right? So it's a quantitative question. Some kind of specification question. If I gave you two sets of results, both regressions on the demand for pork, could you say which one you would prefer for analysis? Could you do analysis using both types and say which one seemed more correct to you? It's important that you realize in this kind of question, there's no right or wrong, but the factors or the argument you make has to be using valid information about the characteristics of each type of model. So if you were using a log linear model versus log linear with homogeneity or log linear with the numeraire, it would be important that you understand what the difference in those two are. Namely that in one of those you have this sort of desired effect that the elasticities all sum to zero so that inflation doesn't cause a problem. Okay? And of course that's in general preferred, but it doesn't have to be. There might be some reason that you don't want to. For instance, calculating all the elasticities directly because you think that the entire budget or the entire spending pattern of this person doesn't zero out on just these three meat items, right? It may include all food before you get to a practical implementation of the homogeneity condition. Okay, so that's always a possibility, and that's one we talked about. Validation question. If a result is inconsistent, for example, you get a positive own price effect, how do you diagnose it? What could be wrong? What could be wrong with a regression? And so we haven't talked about this a lot, but it would most likely come in the form of me asking you, are there things, what would you try? Are there other data that you might use on the right hand side? And so the most common problem there is someone estimating a demand equation and leaving out income. Because if income goes up, but it's omitted or it's left out of a regression, it can be a real problem because you see quantity going up, whether prices go up or down, and it's all because of the income effect. Okay, so that's this validation question, thinking about what's there, and I can tell you it's most likely that I would give you a statement to believe or disbelieve. So either you write something that confirms that statement and you think it makes a valid case, or you think it isn't and you counter that case, right? So a perfect example would be student A estimated that the own price demand elasticity for eggs by a household is 0.1, so it's positive. Okay, so as eggs get more expensive, they consume a little bit more. This is because eggs are a luxury good. True or false, and then validate your answer. Well, that's probably false. If you say true, you need to make the case, right? This what kind of family, what kind of budget, what kind of living situation would make eggs a luxury good? It wouldn't be very typical. So that's probably designed to be false and to have you say there's something missing that's causing that to be positive, or either the data is bad, whatever. And then if I gave you a statement that said they estimated the correlation that's direct between price and quantity and found it positive for eggs, how might you rectify this? And then, of course, adding income to see what role income shifting the demand around is having would be the important part there. And then another specification question. What if I just gave you something like, I said the quantity of eggs consumed or purchased by a household, and I gave you 10 things and said which would you put in, which would you leave out, and then make the case for why. That would be another type of specification question. Okay, that puts us about 30 minutes. That's my target for this. I'm going to process this video and put it up. Remember, on Monday we have open session, so if you come to class on Monday, come with questions, and I will work on the board or just give you my thoughts. I will not have written the exam by Monday, but I will have, I will be farther along. I will have the notes that I'm going to use to write it, but I've basically given you the same notes that I've whittled down to. So between Wednesday's lecture of this week and this presentation, these cover the 2 topics, and that handout gives you something like 4 or 5 different sort of sub-items under each topic. Again, supply and demand analysis or market equilibrium, and then empirical. Each of those has 4 or 5 things underneath that I think have to be tested, and so my goal is that it would be really difficult for you to pick 2 of your 3 questions in each section without being tested on those. So there'll be some things that overlap, but really it's designed to make you comfortable and pick the questions that make the most sense to you. Okay, so that'll end our review time for this second topic.